Okay, we're going to start again. If I can get this thing adjusted. Reference planes. It's kind of, I'm sorry about that. Okay, let's try this. Reference planes. Instead of using one of the planes of projections, you can use a reference plane parallel to the plane of projection that touches or cuts through the object. Again, if it's over here, you got a little yellow note, those are tips. So if you want to read that, so if you're using 2D CAD, you can draw half of the view and then mirror the other half, which I don't do that a whole lot. But the reference plane is, for example, in A there, if I were drawing this, my reference plane would be at RP, okay? You have a front view and then a top view, and then the edge view of the reference plane, which is the line RP, is shown up there in the top view. If you go down in the front view and go to surface A there, or line A rather, there's a surface A at the top, but line A is in the front view. And if you would just offset that line to a certain distance, it could be any distance to the right, and get that, you would get your line RP, and that would be also your reference plane. Excuse me. And B, you could get that, do the same thing with a reference plane, only it'll be in the middle of it, and you could draw half of it. And this is one of those instances where it's symmetrically auxiliary views. You could mirror it to get the other side. You know, you could draw the bottom side of the top view there in your auxiliary, and then just mirror it to the other side, I think. And then non-symmetrical auxiliary views, they basically put the reference plane line on the back side. You're doing the same thing as A, except when you go, you got area C in the top view, line C in the front view, and then when you go to offset, I would just go to offset and go to line C and offset that line RP to the back side. So you got to remember that's the back side of the part, and you're going to be drawing toward the front. Okay. Okay, old school stuff, using triangles to sketch auxiliary views. You can use two triangles to quickly draw parallel and perpendicular lines for accurate sketches. Okay. Place two triangles together so that the 90 degrees are on the outside. Place them on your drawing into the outer edge of the one triangle is along the edge to which you want to sketch parallel. Hold down the triangle and slide the other along it. Draw parallel lines along one edge of the triangle. Draw perpendicular lines along the other edge. Okay, so much for old school stuff. All right. Here's using grid paper to sketch auxiliary views. Okay, so using grid paper to help sketch auxiliary views by orienting the lines of the grid paper underneath your vellum or other transparent drawing sheets so that the grid is parallel to the inclined edge in the drawing. This is another old school when they're talking about vellum or semi-transparent drawing sheets. They're referring back to the vellum as a type of paper we used back in the old drawing days. It was called translucent. It wasn't clear, but you could see through it and you could see underneath and trace it off. In this case, they're just saying once you get your drawing done, if you're doing drawing on your tracing paper, or your vellum, you draw your shape, your basic shape, and then underneath, if you have grid paper, you can turn that grid paper underneath so you see the grid lines that line up with where your auxiliary view is going to be. The sort of old school. All right, here we are using AutoCAD or using CAD to create auxiliary views. Most CAD systems allow you to rotate the grid or to rotate a new coordinate system, often called user coordinate system. That's going to be the issue. I'm a little bit worried. We'll have a little issues with was trying to get that user coordinate system so you could use it. If we were in class, it would be no problem at all. And if there were any questions, I could readily answer them. So that the user coordinate system, so that it aligns with the inclined surface. If you are using 3D CAD, you can create true size auxiliary view by viewing the object perpendicular to the surface you want to show true size. Circles and ellipses and auxiliary views. Circular shapes appear elliptical when viewed at an angle other than 90 degrees, which is straight on in the circular shape. This is frequently the case when constructing auxiliary views. So, in A there on the left, you have a square with a circle in the middle of it, and it's a circle in that view. But when you start projecting lines to your auxiliary, you're going to get an ellipse. That circle is going to look like an ellipse, okay, or an oval, for those that are not familiar with what an ellipse is. And an ellipse is nothing but a circle turned at an angle. So, and on B, there's a lot of lines there, but they're projecting. They got a partial view there in the middle, and they got a front view, top view, and a partial view, and they're projecting lines over to the right to get a auxiliary showing the true size and shape of that arc in that circle. Okay. Hidden lines in auxiliary views. Generally, hidden lines should be omitted in auxiliary views unless they are needed to clearly communicate the drawing's intent. Your instructor may ask you to show all hidden lines for a visualization practice, especially if the auxiliary view of the entire project or entire object is shown. Later, when you are familiar with drawing auxiliary views, omit hidden lines when they do not add needed information to the drawing. So kind of limit your use of hidden lines. To complete the regular views, this is a reverse construction rather. To complete the regular views, it is often necessary to first construct an auxiliary view where critical dimensions will be needed. So if you're sometimes you will need to draw the auxiliary view before you can get the rest of the drawing. Okay, so in this case, probably I'm going to say the left view or the front view right there on the left is going to be drawn, and to get the right view, you're going to have to draw that auxiliary view on the top there and then project down to get your right side view. Okay, we're going to stop there, and I'll pick up here in a few minutes.